Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by the Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar lecture theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, welcome to the third lecture on the course Maritime Structures offered by SwayamPrabha. This course is offered by IIT Gandhinagar from the Department of Maritime Engineering. In this third lecture, which will be a continuation of the previous lecture, we will discuss more about the rest of types of offshore platforms. In the last lecture, we discussed about three kinds of platforms which you would be able to recollect, that a steel jacket type, a gravity based structure and a jack-up rig, where fixed type platforms what we discussed in the last lecture. We understood that the superstructure of these platforms looks more or less similar, but the substructure varies significantly between the jack-up rigs and these two kinds of platforms. Furthermore, we also understood that these structures, being rigid or stiff, attract more forces, and the foundation design of a jack-up rig is different from that of the steel jacket, from that of a GBS. For example, a steel jacket requires a significant amount of driving of pile into the seabed, whereas gravity-based structures rest on the seabed by their colossal self-weight, but they still require skirt piles for improving lateral resistance, whereas jack-up rigs have a specific kind of foundation called spud can. So, one can see that the versatility and the complexity in the construction and installation vary with different kinds of platforms. Therefore, they are not same, although all the three of them are considered to be a fixed type platform. Moving further, let us go to the second type of platform, what we call compliant type platform. Friends, please pay attention to the spelling here. It is not compliant. Compliancy refers to flexibility. Flexibility in engineering perspective refers to movement, freedom of movement, degree of freedom of movement. We call this as flexibility. So, compliant platforms are now flexible type, whereas fixed platforms were rigid type. So, one can easily and interestingly come to a quick summary that flexible platforms cannot resist lateral loads by the virtue of their fixity as being done and conceived in fixed type. So, then how these compliant platforms resist forces? So, that becomes an interesting design concept. So, the flexible platforms have the capability to move along with the external forces. What do you mean by this? So, let us say I have a platform, a virtual idea, I have a platform, this is a seabed, this is my water level. We know I need to have a small draft of the body into water. Based on Archimedes' principle, the displaced volume will impose the buoyancy force on this body. Therefore, the body will be supported by this displaced volume of water. So, the weight of the body will act downward, whereas the displaced volume will give you force upward. We call this as buoyancy, and this buoyancy will support the weight. This is a very basic concept what we have in Archimedes' principle. So, this principle was used in implementing the design of compliant structures and floating structures. So, now when I have a body which is floating, when the body is anchored to the seabed by some wires or some ropes, okay, then the body cannot move freely from its position, but the body can keep on swinging, right. So, the body can move to the left and right up to certain extent. Okay. So, this is the flexibility what we are talking about. In the earlier case of fixed structures, this flexibility was completely absent. So, as the wave hits the body, the platform will move to the right. When the wave hits the body, the platform will move to the left. So, the platform has a capability to move to its left or to the right, pivoting from this point. So, this motion is what we call as compliancy or flexibility. So, this flexibility will enable to reduce the forces on the body. It is very simple. For example, again two friends, this fellow is standing on the floor, whereas this fellow is on skaters. Okay, skaters. When somebody pushes this fellow, he will resist this only by its strength. As long as he is stronger than the force, he will resist. When the force is more than its strength, he will give way. Whereas, if the same force applied to this fellow will keep on moving because he is on skaters. So, there is relative motion between the resistance offered by the person and the force pushing the person will enable the person to resist the load automatically. So, this motion will help him to resist the load. So, resist the load need not be always by opposing the load. Resisting the load need not be always by opposing the load, can always be also by maintaining a flexibility with the load. This is a concept what we have in compliant structures. When the wave hits the body moves right. When the wave hits the body to the left, the body moves to the left. So, this motion relatively will help to resist the force by the body which is acting upon the waves. So, this concept is being used in compliant platforms. The structure becomes flexible and therefore, it responds to external forces not by withstanding the forces, but by undergoing large displacement. So, now the keyword here could be compliant structures undergoes large displacement. Friends, in engineering structures, you have got two types of design. One is what we call strength based design. Other is what we call displacement control design. The strength based design is purely depending upon the member size, material properties and boundary conditions. Whereas displacement control design depends purely on the geometry of the system. We call this in maritime engineering as form dominant design. Form here refers to geometric form. So, the geometric form is designed in such a manner that it resists force not by opposing the force, but by its compliancy or flexibility. So, flexible systems are made to resist force by movement, where we apply something called displacement control. Rigid systems are made to resist the loads by its strength. We apply this as strength based design. So, the design philosophy for rigid systems will be now different from that of displacement control systems. So, slowly we need to understand how the design philosophies also change as we move the geometric design from fixed to flexible systems. So, the methods by which a compliant structure is attached to the sea floor need to be different. It cannot be same as you have a fixed type. In fixed type, you had piles, you had skirt piles, you have caissons, you have spud cans. Whereas in compliant systems, the foundation model need to be different because it should allow you to move as you are encountering the force, like a skater. Okay? So, these structures therefore strongly rely on restoring buoyancy force. That is very important. So, another keyword here is restoring buoyancy force. These systems undergo large displacement. They also rely on buoyancy force to resist, to support the external action. Furthermore, as the wave and wind loads are dynamic in nature, they have a dominant frequency or a period at which they are going to act on the structure. So, it is important that this frequency of the wave, it is important that the frequency of the wave or wind should not be same as the natural frequency of the system. Why we are talking about natural frequency here? Because I am talking about a system which is in motion. It is not moving, but is oscillating. When it oscillates, it has a motion. This motion will have a natural frequency. This frequency should not be equal to the dominant wave or wind frequency acting on the system. If it is equal, then it will cause something called resonating effect and it will damage the platform. Okay? So, it is very important in design that compliant structures also encounter compliant platforms, also encounter dynamic design. It is not that fixed platforms are not designed for dynamic forces. They are designed, but the displacements are very, very minimum. Whereas here, displacements are relatively larger. When the displacements are larger, the frequency of motion becomes very important. Therefore, in compliant structures, dynamic design features are very important. Having said this, let us see some of the compliant platforms. The first one comes into play is called guide tower. Friends, it is not that it is a male or a female. Guy does not mean it is related to any male or female. It is not guy or gal tower. Guy is a term related to these wires. We will talk about these wires later. So, this is the superstructure of the platform. One can see here a drilling derrick, a lifting crane, electromechanical systems, and the support is on a truss. But remember, this truss is not founded in soil. Then how this platform is supported? This platform is supported by something called a guy wire. These are called wires, otherwise called as guy ropes. It is because of this platform is named as a guide tower. So, the point where the guy rope is connected to the system is called fair lead. The point where the guy rope is touching the seabed is called touchdown point. These are nothing but catenary profile cables or wires or ropes. These are otherwise called as guy wires. Therefore, the platform is called guide tower. Guide towers are compliant platforms deployed in water depth up to 600 meters. So, now you see the geometric design is enabling commissioning of the platform from about 300 meter water depth to 600 meter water depth. These platforms also have something called recentering. Let us have a keyword called recentering and understand what is recentering. Friends, I have a bar. I pull the bar by an axial force. The bar will keep on extending, what we call elongating, further elongating as you keep on applying more and more force. When you release this force, the bar will come back to original shape and size. We call this property as elasticity. The best example is a rubber band. When you stretch a rubber band within its capacity, release the force, rubber band will regain its original shape and size. So, upon removal of load, the geometry is regained. Let us argue this in a different aspect in offshore platform. I have a system. The system has got a tower. It is founded by spud can, let us say, spud can, and it is a truss system. Now, the wave is acting to push the system to the right. What will happen? when it is hinged joint here, like an inverted pendulum, the tower will start swinging about this point. When the wave acts here, the tower starts swinging about this point to the left side. So, this acts like an inverted pendulum. Okay. Now, in the presence of force, remember, please listen carefully, I will enlarge this. The force is present, wave is always present. When the platform swings to the right, this wire, okay, will pull the platform back, correct? When the platform swings to the left, this wire will pull the platform back, correct? So, now these two wires are able to apply a force in the opposite direction in the presence of load to bring the platform to equilibrium. This is what we call as recentering. Now, let us understand the difference between recentering and elasticity. Let us say recentering, elasticity. Friends, elasticity is a material property. Recentering is a geometric property. Elasticity happens in the absence of load. When you remove the load, it becomes elastic, whereas recentering happens in the presence of load. Okay? So, I want the system to remain recentered under the action of forces. Why it is required? Because if the platform is placed in position when the loads act, when the platform moves to the right, the platform should have a capability to come back to its position. Why? Because the platform is connected to the seabed by something called risers through which I am exploring oil. So, these risers will get plugged out otherwise. So, I must have a capability to bring the platform to its equilibrium position. So, I do that by allowing the guy wires to bring it back. So, complaint systems are enabled to have recentering ability, whereas this problem was not there in fixed structures. So, guy wires are similar to catenary cables, which will help the platform to recenter under wave action. The foundation of a guy wire is similar to a Spratcan system, which we already saw in a jack-up rig. The next kind of platform in complaint platform type is called articulated tower. Articulation is referring to hinge. For example, if you look at the wrist here, this connection can be termed as articulation. Articulation is a hinge. So, this hinge will allow me to rotate about this point, but it will not allow me to pull from this point. So, hinge will allow me to rotate 360 degrees. Do not keep on doing this because you will not be able to attend the class, right. So, that is okay, but yes, this can help you to rotate, but you cannot move, you cannot plug it out. So, it is similar to this, I have an articulation here. Technically, this is called universal joint. Universal does not mean it can be applied to USA, UK, India and Europe. Universal means it can rotate 360 degrees. So, it can rotate about its plane in an axis, but it cannot move away from that axis. So, it is an universal joint. So, when you have a tower which is superstructure like this and substructure is like this, when you have a tower, when the tower is articulated here, when the wave is acting, the tower will move like this. When the wave is acting, the tower will move like this. Then one can ask me a question, sir, in articulated towers, how recentering is happening? In guide towers, this was happening because these guy wires were pulling them back. Whereas in AT, in articulated towers, there are no guy wires. But look at these chambers. These are called buoyancy chambers. You know, buoyancy is a term which is referred to with Archimedes' principle. Depending upon the submerged volume, it displaces water, that offers buoyancy. Let us look at the larger picture of this in next slide. So, I have a tower. And I have a buoyancy chamber. Let us say the water levels here. When the tower, and there is an articulation here, articulation, hinge. When the wave acts this way, the tower is going to move to the right, correct? So, what happens to this buoyancy chamber? It also tilts. When it tilts, you will notice that the submerged volume on the right is more than the left. Therefore, there is an additional force which is offered by this buoyancy because of difference in submergence. This will now push the tower back. Similarly, if the tower is moving to the left, this buoyancy will try to push the tower back. So, these additional buoyancy reserves will help you to offer recentering. So, friends, in all complaint systems, recentering is mandatory. In all fixed systems, recentering is not required. Can you tell me why? Very simple. In complaint systems, the system undergoes displacement. In fixed systems, the displacements are minimum. So, the compliancy is offered by the buoyancy chambers. As you see, they are located at different locations. At the bottom, you find something called ballast chamber. Ballasting is referring to dead weight. So, we put dead weight here to increase the colossal weight of the platform. You know, I can give an example. Say, a human, okay, on his leg, he is tying a big ball, iron ball, big ball. You know, you must have seen in movies, in olden days, if you want to capture a prisoner, they used to tie a ball to his leg, a solid ball, steel ball, so he cannot run away, right. So, now this colossal weight tied at the bottom will increase its stability and will increase its stability and will increase its resistance to load. Okay, you cannot laterally push this fellow. He will not fall down. Even if he wants to, these balls will not allow. Same story here. I put a ballast chamber at the bottom, increase the weight. This weight will improve stability and the platform will be stable under lateral forces. So, ballast chamber for stability, buoyancy chamber for recentering, single leg and inverted pendulum with hinged connection. Articulated tower. So, the key points of AT are buoyancy chamber, ballast chamber, universal joint, recentering. If you have any specific questions, please note it down so that you can put me at the end of this video later. Having said this, let us move on further to the next type of complaint platform called tension leg platform. Tension leg is a phrase to be read together, shortly called as TLP, tension leg platform. Very interestingly, friends, tension leg platform is one of the most successful complaint platform ever installed in maritime sector. It's very, very popular. The design was conceived very interestingly. Look at this platform. I'll draw a separate figure to make you understand the concept of this platform. To be very interesting, friends, my PhD is on tensional platform. So, I did extensive research on this. About 120 papers which I published so far, 85 papers on research publications are on TLP. Okay, that is for information. You can look at my home page drsekaran.com. You will find lot of papers on TLP. Let us look at the concept of TLP first. I have basically a solid box which is, let us say, having some thickness. So, let us take a box with some thickness, put it in water. You know when this body will float in water? This body will float in water only when the displaced volume of this body inducing buoyancy force is larger than its weight of the body, correct? When the weight of the body is more than the buoyancy, it will not float, it will sink. So, the amount by which it resists in water is called draft. Okay. Usually this draft is approximately 1/3 to half of H, approximately, friends. I am talking only about simple terms to remember. So, now I have a box, I have a big box. Now, the box is solid. If it is solid, then this is my buoyancy level. If it is hollow, then the buoyancy level is same. Can you tell me why? Because the buoyancy does not depend on weight, depends on the size of the box, because the buoyancy is proportional to displaced volume, not weight. Okay, if you have a size of L, B and H, proportional to this volume, I will generate buoyancy force. Let us say the buoyancy is very, very high compared to the weight. What will happen to the body? The body will completely float, correct? The body will fully float because the buoyancy is exceeding its weight. This is what we call as design concept of TLP. The design concept of TLP is buoyancy exceeds the weight. What is the advantage of this? I have a huge platform. I want to commission the platform. If you have this condition fulfilled, I do not need any special installation methods. I can have a box, okay, drag the box with a vessel at any point and commission the box. I do not need any special installation procedures for doing installation. Like we said, jacketing, appending, etc. all will be saved when you have a TLP. But when buoyancy exceeds the weight, the body will be keep on floating. It will not rest in any specific position. So, what I do? I have a box. This is a seabed. I want to connect this box to the seabed with simple wires. We call these wires as tethers. They are steel wires. Approximately the diameter of the wire is about 100 to 120 mm. Solid wires, they are pipes actually, they are tubes, and each will have about 8 sets, 16 sets, 24 sets. I am talking about each one of them is 60 mm. So, this is a group which I am seeing here. It is a thick tube. So, these tubes will be connected and they will act a downward force to the system. So, now if the buoyancy exceeds the weight, let us say buoyancy exceeds the weight is acting downward, buoyancy upward. So, I should have some additional force to equalize this. This additional force is T naught, which we call initial pretension. So, when I have W and T0 acting together equivalent to buoyancy, the system will remain in position. Okay. Now, I want to remove the system and take it away to another location. What should I do? I can simply cut these tethers. This will go away. Buoyancy exceeds the weight. I can tow this. So, it becomes very easy for me. So, the commissioning, decommissioning, installation becomes simple compared to fixed type platforms, and the platform is completely reusable. So, sustainability has been brought into place in maritime structural design automatically by the geometric form. So, TLPs are one of the most successful geometric forms of maritime structures meant for oil and gas exploration. So, let us go back to this slide and understand how a TLP looks like. So, these are called as columns. This is called as a pontoon. Then on the top side, you have a deck which has drilling and process units. So, since this part of the drilling component is kept above water, this is called a dry tree. When this component is kept in the seabed, it is called wet tree. So, now TLPs essentially have dry trees. So, these are what you see here are the tethers. The technical name given to the tethers are called tendons. Okay, tendon is not somebody's name, so please understand they are technically known as wires or tethers. They are also called as tendons. So, tendons will apply axial pull downward. Okay, these are called drilling risers. So, these are tendons. Okay, this one and this one. They will apply axial pull downward. So, axial pull called T0, buoyancy upward. So, buoyancy upward, T0 downward, W downward. So, buoyancy upward should be equal to W plus T0. Okay. So, this is my static equilibrium equation for a TLP. Something called TLP mechanics is quite interesting. TLP mechanics. When a TLP is commissioned, when the wave is acting, TLP will move, correct? So, look at this figure clearly. There is an inclination to the horizontal. There is I can enlarge it further. There is an inclination to the horizontal. We call this as set down. Okay. There is a motion to the vertical. We call this as offset. An offset is an horizontal motion, set down is a vertical motion. And when you have a set down, offset is automatic. When you have an offset, set down is automatic. So, set down and offset are something called coupled to each other. When you have a set down, offset will be there. When you have an offset, set down will be there. Please note friends very carefully. Offset is much larger compared to set down. I repeat again, offset is much larger compared to set down. Set down is very small, offset is very large. Can you tell me why? Think about it. Set down has to be small because set down will also offer buoyancy, will influence buoyancy. The statics depends on buoyancy. Therefore, I should not have a large buoyancy variation to change the dynamic properties of a TLP. So, very small set down, very large offset. Okay, now let us see how recentering happens in a TLP. Look at this figure. I am drawing a TLP again. I am drawing tendons anchored to the seabed. Let us say this is my draft. what we call dr. Okay. Now the wave is trying to push the TLP to its right. What will happen? The TLP will start having an offset and a set down, correct? So we call this as offset and this as set down. Am I right? So now these tendons will be again connected only, they won't get disconnected. So when the platform moves to the right, remember again, listen carefully, when the platform moves to the right, the horizontal component of this will bring the platform back. When the platform moves to the right, the horizontal component of this force will bring the platform back. That is recent. When the platform moves to the left, the horizontal component of this platform will bring it back. That is called recentering. So, in a compliant system, recentering is automatic to be designed by the geometric form. It happens in jacket platforms, it happens in articular towers, it happens in guide towers, it happens in TLPs also. Okay. So, we call this as TLP mechanics. Okay. Having said this, let us move on to the next kind of offshore platform, which is called single point anchor reservoir. A single point anchor reservoir, which is called spar platform, consists of a single large cylinder of a very large diameter. The cylinder also has the buoyancy chamber filled in to improve the stability. Now, how the recentering happens? Here, I have a platform connected by a single large cylinder and then anchored to the seabed. This is my water level. So, the deep draft will offer excessive buoyancy and that will support the platform. Okay. Recentering happens automatically because when the platform moves to the left, the change in buoyancy will automatically incur recentering. So, recentering is automatically happening because of the chamber attached to the cylinder. So, there are three types of spar we have in reality: a classical spar, a truss spar and a cell spar. A classical spar has a cylindrical hull, a truss spar has a short cylinder called as a hard tank, whereas a cell spar has a large central cylinder. Depending upon the size of these and position of these cylinders, they are named as classical spar, truss spar and cell spar. Having said this, let us move on to semi-submersibles and drill ships. So, Blind Faith semi-submersible is a very famous semi-submersible platform operating in Korean and Tanzanian waters. It is also available now to operate in Malaysian and Indonesian waters. It is same as that of a ship which has got legs which are partially submerged when they are in operation. That is why they are called semi-submersible. They are completely floating structures. So, friends, we have now moved on from fixed to compliant to floating structures now. So, the floating structures do not have, this is a seabed, do not have any substructure, friends, whereas the fixed type platform had a substructure, compliant type platform had a substructure, whereas floating type has no substructure at all. They are completely floating. Okay. Example, drill ship. semi-submersible, etc. So, semi-submersibles are fully floating structures used for oil exploration. They are towed to the site, ballasted and moored, anchored to the seabed for operation. They have a very large vertical columns which are connected to large pontoons which help them to float. The lower part of the semi-submersible rig rests on the seafloor to enable drilling. Typically, they have two types of chambers called air-filled steel floats called pontoons. They are large in shape and size. They will help them to float and can be used for oil and gas exploration. Since part of this vessel is in water, they are called semi-submersibles. We also have something called FSO, FPSO. F stands for floating, production, storage and offloading platforms. The concept of these platforms are similar to what you see in semi-submersibles and drill ships. Now the question comes, how a drill ship is anchored to a seabed. For example, drill ship is a vessel which is sailing in water. Okay, this is a water depth. They operate at a water depth of 1500 to 2000 meters. Deeper waters. They are fully floating. How are they positioned, restrained and anchored? They use something called position restrainers, dynamic positioning system, DPS, dynamic positioning system. So, what they do is, they have a sensor on board. These sensors read the X, Y, Z coordinates of the position of the vessel. If the vessel is moved to a new position, this position is changed, they will try to invoke the thruster. The thruster will apply a force in the opposite direction to bring back the vessel to its position. So, they are called dynamic positioning systems. Sometimes for additional safety, they also have something, anchors. These are additional safety. Of course, drill ships can survive even without anchors. Okay, even without anchors, they can survive. So, friends, FPSO, FSO operate in the same manner as semi-submersibles and drill ships. One of the classical FPSO operating in Indonesian waters is Greater Plutonio, and that is how it operates. A vessel fixed with the helipad, and it has got all drilling riser systems, and the vessel controls this and takes away the oil back to the seashore. So, these systems, as you move from a fixed type to a floating type, the type of foundation, type of structural system, recentering mechanism, anchorage, all varies in design. So, friends, let us write down the summary, what we learned so far in this lecture. So, lecture 3, we say summary. We have learnt in this lecture compliant structures. Compliancy refers to flexibility. These structures can operate in deep waters. We have seen guide towers, articulated towers, TLPs and spar. Then we move to floating structures. We have seen semi-submersibles, drill ships and FPSOs, which are all operating in depths more than 2000 meters. So, we learned that the substructure design is different. They need recentering ability. They don't need foundation in terms of floating structures. They all have large displacement. So, we know the design will be now controlled by displacement control. Okay. So, friends, with this lecture we understand different types of offshore platforms used for oil and gas exploration, and we have learned how the design can be modified and altered depending upon the water depth where they operate. If you have any questions, please post it to SwayamPrabha. We will try to answer them in the discussion forum, and also try to answer the tutorials posted to you on the lectures, and keep a constant pace of learning for this course. It is quite interesting and it is very job opportunistic, and you will also have some novelty to learn and read from this course. Thank you very much. Namaste.